Welcome. Hopefully everyone is gotten something to eat on the lunch and are ready to hear something about Lambda-related development. So, you can't develop AWS Lambda functions locally. Debugging with Lambda is slow due to constant redeploying. Feedback loop is very slow with it. And testing Lambda functions is complicated. These are just some of the examples of, let's say, FUD, fear, uncertainty, and doubt, and the questions that I often get about AWS Lambda. And actually, the idea for this talk came in this year, June, in Stockholm, some AWS Summit, where I think at least 3 people approached me with these kind of questions. So I thought it might make sense to actually talk about it a bit. So I'm going to share some practical tips about developing AWS Lambda functions with TypeScript. And I'm going to focus on the Node.js and TypeScript combination. Many of the tips here will be applicable to Python as well, and also the other languages. And a bit of a quick introduction. I'm Palo. I'm head of cloud at Alma Media. Been there actually 14 years now, so a long time Alma Media person. Been using AWS since 2014 myself professionally, and jumped into serverless bandwagon in 2016, and many of you might know me as a big AWS CDK fanboy since I've been using it since late 2018, and also an AWS community builder. And I use a lot of TypeScript, but I really love Go. And if you want to connect, there's some keywords. I work at Alma Media, and Alma Media is a digital services and media company based in Finland, but actually operating in 11 countries. So Finland and here in Sweden as well, then Baltics, Eastern Central Europe, all the way down to Balkans. And to give you some context, I think we have, was it last week I checked, we have 408 AWS accounts, and the number keeps growing all the time. And the agenda for today is that first I'm going to describe some of the common challenges that people seem to face with Lambda development, and at least I have faced back in the day. And then I'm going to describe my local to cloud approach. That isn't any kind of official term that I now have coined. It's just something I happen to call it. So local to cloud approach, which basically can describe anything that you're doing with cloud, because usually that starts locally. But it sort of consists of strict contracts, unit testing, integration testing, and ephemeral environments. And then we're going to wrap this thing up. So first, the common challenges. Well, with Lambda, you just deploy some code and AWS takes care of the rest. That's kind of the magic of AWS Lambda. But it's very simple to use it, but it often also leads to this simple mindset about the development process. You just code something, you deploy it to AWS, and then you start debugging it. And that kind of a workflow is very, very slow, especially if all the changes that you want to debug or test involves a redeployment. So people, and also me in the past, have figured out that, okay, it doesn't necessarily always make sense to deploy and then debug. That's a slow feedback cycle. So let's instead somehow invoke the function locally. So we sort of skipping the deployment part to AWS. So there are multiple ways you can do it. Most of them somehow utilize some kind of a containerized setup that is emulating the Lambda runtime environment. And one of the ways you can do it is using the SAM CLI and its local invoke command. But as Mateusz today was actually showing about the local stack, and you can also achieve similar things with local stack. And so there's multiple solutions to it. But with this approach, it also often leads to this, what I call happy path only development. Because this, if we jump back one time more, you see you usually have this event.json that somehow describes the payload that will be sent to your Lambda function, and then you just throw that JSON back and forth to your Lambda function code that is now running in local emulated environment. And that often leads, I'm not saying always, but can lead quite often to this situation of happy path only development, that you just have this one event.json file and you're spamming it all the time against your code. And what I mean by happy path only development is that you're basically sort of debugging and testing one case only. You're not testing multiple different scenarios. Okay, You can easily solve that by having multiple event.jsons that you are passing around into your function and testing multiple other different scenarios. Of course, managing this might be a bit tedious, but we are developers, we can figure that out. But then comes the next challenge. Like, what do you do with other cloud resources? Usually, your Lambda functions don't really exist in isolation. They need to talk to external world. It can be, of course, some totally external resources outside of AWS, but for this example here, let's say that it's talking to few AWS resources. Could be S3 buckets, DynamoDB tables, SNS topics, whatever. So how we can actually solve that? Like, that can cause a lot of confusion sometimes if you're just starting with Lambda development, and you sort of, as we saw in the previous slide, we have already solved the local invocation of Lambda, but how we manage the other cloud resources? Well, two common solutions I've seen people take is either using the real thing or emulating again. Actually, for the emulation part, there are multiple tools. If it's just DynamoDB, AWS offers this DynamoDB local that you could use. Then there's the local stack that Matthias again was having a fantastic talk today about. And then other people might choose to actually use the real thing. And there are pros and cons to both of these. Using the real thing, meaning deploying actual resources to AWS, well, it requires deploying those resources to AWS, which can take a bit of time, and you need to manage that as well. It requires authentication, so your laptop where you're developing must authenticate to the account that has those resources. And yeah, that's like, you're using the real thing, so you're actually debugging and testing against the real cloud resources. So there's a benefit to that, but there are disadvantages. Then, if you choose local stack or some other way of like emulating the cloud resources, it's usually faster in that sense that you don't have to think about authentication and everything is running locally and that kind of thing. But then there is the challenge that there can be parity issues. So there could be like things that are not working as exactly in the cloud they work. And the other thing is that it's still, even though, especially with local stack, you can sort of use SAM templates or CDK and generate the local stack infrastructure from those, it's still something else that you need to sort of set up, configure, and maintain. But even doesn't matter which way you choose, there are still situations that can happen from that. Let's say you have DynamoDB table or something as the other cloud resource. So do you actually, in your day-to-day development, do you then handle, let's say, partial or invalid data, or situations where you might be throwing too big messages to DynamoDB, or any other errors that might happen when communicating with the other cloud resources? So again, this is kind of a happy path development that I see often when people are only either emulating everything on their machine or just a Lambda function and then using actual resources in AWS. So, and then let's switch gears a bit and let's consider the code itself. The other thing that I see quite often when people, especially when people are starting with Lambda development, is that these kind of a naive coding practices. And this is like, let's say, heavily inspired code from like real world things that I've seen throughout the years. Of course, the code itself doesn't really make sense, but just a few bits and pieces to demonstrate things that I have seen. So way too complicated, like if statements. That is even quite simple one, but like you get the idea that we're checking like if there's thing available in some deeply within some object, and then maybe doing something, and then other common mistake is like assuming some data is available in the payload and these kind of things. So for some reason, when developing AWS Lambda, because let's say the way how Lambda works in the surface, it's quite simple. So it sort of leads to us into this simple mindset that we throw away all the best practices, all the tools, and all the concepts of software architecture and these kind of things. So now that we've gone through some of the challenges that are like, definitely those are not all, but those are, in my opinion, are the common ones that people seem to be hitting when developing Lambda functions locally. So let me describe my approach. And this is kind of like my way or highway situation. So you don't definitely need to agree on these, But at least after this, you should be aware of these options. And hopefully the fear and uncertainty and doubt regarding how you can work with Lambda functions and develop them locally goes away. So first thing in my list is strict contracts. Second, unit testing, and crucially fast and very, let's say, robust unit testing. And then integration testing, automated one. And finally, ephemeral environments for actually debugging things in the cloud environment. I'm not going to talk about the software architecture in relation to AWS Lambda like that much. So there's like more qualified people to talk about onion architecture, so hexagonal architecture, so any kind of architecture decisions you might throw at Lambda development. But I'm going to focus on these strict contracts a bit because I think it's useful in many ways. First, by using strict contracts, you avoid those silly mistakes that can happen easily, especially if you are doing any assumptions on what kind of a data is available in the incoming payload for Lambda. And it makes your code base more maintainable. And in this day and age of Gen AI, I think it's more promptable, so to speak. And how you achieve that? Well, of course, for strongly typed languages, that is a mostly out-of-the-box solution. Because of the language itself, you just need to add some data validation there. But for dynamic languages like TypeScript and Python, you need some other tooling there. For TypeScript and the runtime JavaScript, I really like to use Zod. It's a fantastic tool. And then for Python, there's Pydantic, which is kind of a similar tooling. And you may think, what are these tools if you haven't heard them before? So here's an example of Zod. It's basically a schema validation and data parsing library. And it works that you define the schema. In this sense, in this example, we have this user object schema with just a name field, a very simple schema. And then you have some input, could be anything in there. And then you throw it to the schema and parse it against the schema. And once you have parsed the data, it is strongly typed and it gives you confidence on how you can actually use it. And I use Zod to parse everything sort of external when it comes to developing Lambda. So the Lambda event itself, and I don't just mean the payload, also I mean just let's say if it's an API gateway event, I don't just mean the body, but the whole payload. But of course, everything that is dynamic, like the body part in API gateway responses or anything else, I definitely want to parse with Zod. Environment variables, external parameters, API responses from some HTTP endpoints that you might be calling, database responses, etc. So pretty much everything I use Zod to parse. And actually a pro tip, they just released this new feature called Codex, which is pretty nice for data transformations. But before you start going npm installing Zod and trying to figure out like how does it even work, you don't need to start from scratch. There is this AWS fantastic tooling from AWS called Power Tools, available for multiple languages such as TypeScript, Python, Java, .NET, and yeah, that's it, I guess. But they actually provide a lot of features, and you should use Power Tools if you're developing with Lambda. Not just because of the possibilities that they provide for data parsing, but they have a lot of features that actually increase the developer velocity as even their own documentation states. But the thing is that with Power Tools for a TypeScript, it comes with Zod by default and some predefined schemas for many common scenarios, for many common Lambda integrations. And similarly, for Power Tools for Python comes with Pydantic and as well some predefined schemas. So you get up to speed very fast. And here is again the same example from before. So I like to think of this, that especially the first part where we are checking like with if statements that does some value exist and then maybe doing something. So that's kind of a validation that I want to avoid. So instead of validating, I like to think about the parsing. And there's a fantastic article if you Google parse don't validate, and it explains the concept more in depth. But the main point is that you transform some weak input types into strong output types that have guarantees in the type system itself. And if we take a look at it on the Lambda development, sort of situation? Well, you import the JOD, you define the schema. Again, we have the simple user schema here. And then we use the predefined API gateway proxy event schema, and we extend the body part of it with our, let's say, use case specific schema. And then finally, we use MIDI. There's other ways you can use this, but MIDI is this like middleware tooling available for Lambda, and we configure it to use the schema, and the end result is that the event itself, and as you can see also the event body in this case, are strongly typed now. And as I said, Power Tools has many other features as well, so definitely go and check it out. And I think after this talk in room 2, there's actually a session about Power Tools, so definitely check it out. Then, unit testing. This is, I think, the most important part of my local development workflow. So instead of like emulating the Lambda function locally and just throwing a bunch of JSONs against it, I really like to approach Lambda development by unit testing. And in these situations, I consider the external world, basically everything outside the Lambda function, as a mock. And quite often, the inputs that go towards external world, it could be like AWS SDK call to, I don't know, let's say DynamoDB. I often test those inputs and I verify that the request that is going out of the Lambda, that works as expected. And then in the mocks, then I sort of the outputs, let's say, for example, AWS SDK responses or whatever, those I will mock and then test how my application code actually reacts to various situations. For example, if there's an error calling the database, or if the data coming from the database is somehow partial or invalid or something. So you can create quite a lot of different test cases and basically avoiding that happy path only development when you do that. And some of the key characteristics of this is that those unit tests need to be very, very fast to execute. So you get this like very rapid feedback loop. And the test runner that you're using, it basically needs to, or at least should have, this like watch mode that reacts to changes in your source code and your test files and reruns the test every time something changes. This basically enables the fast feedback loop. And finally, high code coverage, and especially in these days with Gen AI, there is no like excuse for not having high code coverage. For this, I personally and within our company, we like to use vtest. There's alternatives, yes, and even these days, Node.js has a native test runner. But let's say the key points are, again, it needs to be fast, which vtest is. It needs to have good mocking capabilities and that watch mode. That is important. And here's a simple demo. This is running the test in CLI in watch mode. You could use some IDE extension also to run the test. But the point is just being that the tests run really fast. When I make any kind of edits to the source code, the tests are re-executed again, and I can see something failed, and then I fix the issue, and everything goes to green again. So this is the really fast development cycle that I like with Lambda. And one pro tip, if you set the timeout, at least in vtest, if you set timeout to 0, it means the timeout is infinite, meaning that you can actually launch the test in a debugger mode, so you can actually use the IDE's debugger while you're executing the tests. And then we get to the sort of interesting and somewhat also annoying part of unit testing, is like the mocking part. When you mock the external world, as I call it, you end up mocking the AWS SDK client calls. There is this fantastic library, AWS SDK client mock, and also vtest sort of additions to that. And they get you started really fast. They are fantastic libraries. Only problem that I have them is that they haven't been really actively maintained lately. So it's a bit of a questionable decision that would you want to use those. I actually really would wish that AWS would basically publish something similar themselves, like an official tooling, because this one is like a community-built tooling. Fantastic tooling. I have nothing against the developer, so fantastic that he has created it. But this is, I think, crucial feature that should be sort of released and maintained by AWS maybe. But the other approach is that all the modern test runners, they have mocking capabilities. And in the end, it's not that hard actually to mock AWS SDK yourself. So you can definitely do it. So that's the other approach how you can do it. And basically now we reach the point that we have a very fast local development cycle. Those strict contracts force us to sort of not do, let's say, the silly mistakes, and also sort of guide us in, let's say, better development practices, and then using the unit testing in watch mode to get very fast feedback loop. That's very nice experience for development. And then we talk about integration testing. I actually have this approach for integration testing that I prefer to do the test in AWS environment, actual AWS environment. Again, as I mentioned, Mateus had fantastic talk about local stack, and I'm sort of maybe might have to actually take a new look about that. Might be interesting way to solve the integration testing part. But then again, the integration test to me is like important to verify that it works in an actual real environment. And we will later talk a bit about ephemeral environments, so the cost shouldn't be that bad either, or anything like that. So integration testing. In my mind, this must not have mocks. There can be some exceptions, that some sort of external things that you don't own that you might mock in some cases, but I think the crucial part is at least to test how if we think about the context of Lambda function, in that scenario, at least the important thing is to ensure that everything that it integrates to directly is working as expected. So they are definitely slower to execute, and usually you don't test everything possible there. You can definitely, but that can make the test really slow. So it's a balance you need to find. But other thing is that you should consider, I've seen people doing it the other way as well, but you should definitely consider deploying those integration testing resources into ephemeral environments, which I will talk soon more about. Some tooling that you might use. Well, you guys, or some of you might know me for like being a big CDK fanboy. So there is some tooling in CDK for running these kind of integration tests that I will demonstrate next. But the other alternative that actually I've also used quite a lot myself is just using an existing test runner, which is nice because it's kind of, you're familiar with the test runner that you're already using, and then just using SDKs or CLIs or however. So basically just deploying part of the infrastructure you want to test, and then using the test runner, wrapping assertions in it, and then using AWS SDK to make those assertions about your infrastructure. Here's an example using the CDK intake testing tools, but let's say the concepts apply to however you want to do the integration testing. We have some stack containing some resources that we want to test, and importantly, we want this actually deploys the stack with those resources, and importantly, after the test is complete, it has to clean up those resources, so delete them. So we don't want to have those unnecessary resources generating any spend or anything like that. And once we have something deployed, we need to define some assertions, like how the thing should work. This is again very simple example taken. I think I took this from some AWS samples repo some time ago already, but the concept is clear. We just, in this example, publishing some message with SNS. Then we are checking that did the assumably this, actually I didn't have a diagram about this, but the idea here being that we have an SNS topic, Lambda function reacting to that, and then something happens, something is stored in DynamoDB. So here we are checking that if the item is in DynamoDB, and then we just check that does it actually look something like we expect it to look. So this was the example with the AWS CDK intake runner, but the same concept goes to if you use like your test runner and then SDK. So you deploy some infrastructure, you do some assertions to it, and then you finally you destroy those resources, so they are not there unnecessarily in your AWS accounts. And talking about those, let's say, ephemeral environments or temporary environments or short-lived environments or feature environments. There are many different names people like to call these. I like the name of ephemeral environments. The idea here is that they are usually created by the CI server and also destroyed by it, either during the integration testing phase, but you can also use these kind of environments for other testing and debugging. So for example, manual testing and debugging, we do this quite a lot, that we have certain rules that if there's a certain branch prefix or something like that, or a pull request is opened, then stacks are being deployed, new infrastructure is created. But once the pull request is closed, then the environment is actually cleaned away altogether. And idea being that for some time, as long as you need it, there are some resources that don't have any connection to other environments, and you can freely debug and test those. So this is part of the integration testing, but this is also part of like manually playing around and understanding what's happening in your actual cloud environment. And of course, you should have a lot of environments for different purposes. We have this pattern of having 2 accounts with different kind of environments. So in dev account, we have these. Sometimes we have, depending on the setup, we might have shared development environment. Usually we have lots of those, what we call internally feature environments, but basically those ephemeral environments. We have multiple of those. And then we have stagings, pre-productions and production, and pre-production, production, live usually in production account. But the point here is that you shouldn't like follow exactly this kind of a way. I think there's many AWS presentations about how AWS handles different accounts and environments, and you have your own conventions. Key point being here that there are multiple environments, and you should utilize the ephemeral or temporary or short environments, which you can freely sort of bring up and destroy as needed. And yeah, that was just about that. But once you have those feature environments, you can sort of play around with them, test like whatever manual testing you want to do them. So it's good to know the tools that are then available for debugging those kind of environments. So one thing is that I definitely use quite often is the CloudWatch logs live tail, meaning that you can choose one or multiple CloudWatch log groups and then follow what's happening almost real time in your application. And you can use it through the CloudWatch console UI or the CLI. And now, was it maybe month or couple ago, they announced the editor integration through the AWS toolkit. So you can get the logs directly in your toolkit. So this is handy when you're actually testing something in those ephemeral environments and trying to understand how your application is working. So you get the logs directly to your sort of computer or CLI or editor or however you want to set it up. And the other thing is there is now also support for remote debugging in VS Code editor. So you can, again, using the AWS toolkit, you can connect to an actual like a Lambda function that is running in AWS environment and throw some payloads against it and actually debug how it's actually performing in the real environment. So that was a very short sort of description how I have been approaching the Lambda development, especially locally, and trying to get it into the cloud and understanding how it works and performs. So wrapping it up, we have the local development using like helped by the strict contracts that sort of force us to be very specific and write a bit more maintainable code, hopefully. Then we have the unit testing setup with watch mode that gives us this instant feedback, and we're able to like develop really quickly things further. And finally, when we push something, we trigger those integration tests, and we can utilize those ephemeral environments, and we get some actual feedback from real cloud environment. And these are the, let's say, the 4 main things how I think about developing Lambda functions. So hopefully those gave you some ideas how you can approach Lambda development yourself, and especially hopefully it removes some of the FUD, as I say, fear, uncertainty, and doubt what is sort of related to the Lambda function and developing those things locally. So that was it. There is the QR code where you can give me feedback and also some contact